Hi, welcome to my YouTube channel. I'm Nathaniel King and your host for this session. I have over 25 years of experience in working with computer software and over 7 years of experience working with cloud and AI. In this session, we will cover canonical model for integration. By the end of this video, you will understand what a canonical data model is and why it is critical for large Azure integration projects, and how you design uh, one that connects systems like Salesforce, Workday, Maximo without spaghetti transformation. So what happens is if we use point to point, I'll show you how it looks like when you have point to point integration. Sometimes it becomes spaghetti, and if you have like 40 plus systems, it's just a nightmare. Just want to make sure that you get the idea. So you know building a single language for all your enterprise systems. So canonical model is very much like a language. So if you are ever connected more than two enterprise systems like Salesforce, Workday, because I'm naming these systems because I use these systems, Maximo, Dynamics, or Salesforce, or ServiceNow. So you already know how messy point-to-point data mapping can become. So canonical modeling fixes that. So it introduces like a one shared common language across your enterprise data ecosystem. That's what I'm saying. It's like a new language which can talk to, or which can be used to communicate in a unique way, right? So if you move forward, then we have, I'm trying to show the problem in the most enterprise, or more, every system talks to in its own language, right? Salesforce uses, like lead in opportunity, Workday talks in worker and position, Maximo thinks in assets and jobs. So they have their own unique, or say domain, put it this way, and they have their own objects and own model, and it's very difficult to communicate with other system. So it means we need someone in the middle interpreting what's happening. So when each system maps directly to every other, the number of connections grows exponentially. So you have n systems and m connections. It becomes n multiplied by m proportion. So this is a dreaded spaghetti architecture you just see on the screen. Now you can see the various lines are going on. So the hard line are actually the connections between Workday and Logic App and Dynamics 365, and then ServiceNow and Maximo. So they're connecting to each other via Logic App. However, the dashed line shows the actual data conversion is happening, or data change happening in between these systems. So to Workday to understand ServiceNow, it has to have data which Workday can understand. Similar with ServiceNow, so you have uh, two different conversions happening, transformation happening between Workday and ServiceNow. Similar way, Workday and Dynamics 365. Similar way, 365 and Maximo and ServiceNow, same way. So we have, if you look at the number of system and each multiply by two connections, so it automatically 8 connections. Now if you have 40 different systems, then you can imagine how many. I'm just saying two conversation, because just like it took one call for Workday, one call for ServiceNow. So I'm just talking one each here. However, in reality, it is more than that. So you need to have different kind of models. For example, for Salesforce, you have leads, you have opportunities. For Workday, we might have worker and their position, and all kind of stuff. So what I'm trying to say here is that when the number of system increases, it increases the number of the complexity of the system as well. So we need to be aware that when we do point to point connection, it will increase the complexity. Uh, so to avoid that, we have canonical model. It's a common enterprise schema to share for a shared data concepts. Each system maps to and from the canonical, not to each other. So decouple system and simplifies transformation. So what I'm trying to say here is that canonical data model defines a common structure and naming for shared business entities. Things like customer, employee, asset, or work order. So there are generic um, um, a model. So instead of every app translating directly to each other, they all translate to the canonical format. So we have a standard, we consider as a standard model in between the systems. So model, we do not have to convert from X system to Y system, but we will convert from X system to canonical model, and canonical model is a common layer among all the systems. That means Salesforce knows how to speak to canonical model, Workday knows how to speak to canonical, Maximo does too. So the result is one transformation per system, not dozens. All right. So that helps in reducing spaghetti. Now Azure architecture for canonical models, integration layer. For example, here is logic apps, functions. We have transport. um, Now you can see here that once we have canonical model, we have one connection each, because JSON is sitting in either uh, in a storage. So from where then we can pick the file, JSON file, and we can transform it as per our need. So in Azure, canonical model live at the heart of your integration layer. So it's very important to understand that uh, each inbound connector, like for example, say Salesforce or Workday, it passes through a logic app. You can see in the diagram, um, and Azure function could be any of those two things, which transform the payload into canonical JSON message. So let's, for example, message comes from Dynamics, this goes to JSON, sorry, to Logic App. Logic App reads a message from the JSON file from the storage and converts the message from Dynamics into that JSON, which will be passed to other system. Uh, Now that canonical message is then published to a service bus or event. I haven't shown service bus here, but normally it goes to service bus, um, and then from there another logic app it transforms back into what Maximo can understand. So downstream subscribers like Dynamics, Maximo, or other systems consume it and transform it back to their own structure. All right. So now you can see there's an example of canonical model. It's a employee, and you can see here version, employee ID, first name, last name, email, employee name. So this is are more aligned to the business rather than to a system. So canonical model is based on systems. So I will talk about a little bit on how to define these things. So this is an example of how it looks like. It has some validation rules as well. It has the field, which will be the common language among the systems. Now you can see here this another flow I'm showing here, Salesforce to Canonical to Maximo. So from Salesforce it goes into a logic app ingress, and it basically goes to topics, and any system which subscribes to this topic will get the message. So from here you can see here we have canonical data stored in storage. So from ingress, the Salesforce message converted into canonical model. It goes to pipeline to topics. From there, it goes to another logic app egress, and then it goes to IBM Maximo. So similar way, from IBM goes ingress logic. It calls canonical model, and then it goes into topics and subscribed by Salesforce from through logic app. So that way it works from understanding point of view. Now, what are the benefits of using? Why should we use it? I mean, why should we do so much of exercise? So the first thing is reduced mapping complexity. So we have one common model, and all services, all systems adhere to it. So they have to, anything that comes in, new comes in, is easy to onboard new system. So basically, we have a standard message, and every system which comes to on board, they have to adhere to that message. that's the syntax or the structure. So instead of instead of managing dozens of brittle point-to-point mappings, you maintain one mapping per system. And when you onboard a new SaaS platform, you just connect it to the canonical model. Not every other app in your enterprise. So basically, we're not connecting to system to other system. We're connecting to canonical model, and other system understand that canonical model. So it stops, it stops our worries to how is going to other system going to understand it. So we other system is going to understand because we have canonical model in between. So that helps other system. The governance improves because of these things, because we have version, we can do versioning of it. We have one common place in repository. Reusability increases and integration cost drops dramatically. So initially it looks like it's going to cost much, but once we have established canonical model and all systems are talking through canonical model, then it's easy. Then it's not very difficult after that. Now, what are the key components of any canonical model? So we have data entities. I've shown you the example earlier. Data entities, attributes, relationship, standardization rules, validation logic. So we put all those things into any canonical model. So data entities are entities represent real world objects like customer, product, or invoice or something similar. Each entity is defined and reused across services and systems. So if we have Salesforce, it understands it. Similar way, Maximo understands it. Attributes are the field names. Each entity includes standardized attributes that agreed upon formats, naming conventions, and data types. For example, customer ID is always an integer, and email follows a strict pattern. So these are examples. It's a very very common and understood by all stakeholders. Relationship. So entities relate to one another. For example, customer places multiple orders. These relationships are clearly defined and consistently enforced.